Well, what's up, guys? I'm Mr. Lanigan. This is Easy Mode Math, and today we are talking about some students' most difficult topic in Algebra 1, Algebra 2, college algebra even. I mean, there's lots of places where we talk about systems of equations and solving them by elimination. And for a lot of students, this is a really tough topic. So let's try to break it down into an easy way for you guys. We're going to be doing multiple videos about elimination, and we're just going to start off with the basics here today. So the word eliminate is a verb, and it means to completely remove or get rid of something, a policy that would eliminate inflation. Okay, pretty cool, right? So that's what we're doing here in these types of problems. We are removing something, we're getting rid of something, we're eliminating it, okay? Most systems use x and y as their variables because the coordinate plane and the points on it use those variables. So those are typically the variables that we're going to use. With systems of equations, we want to eliminate one of those two variables. Okay, that's our goal, is to get rid of one of those variables. And just as a reminder, a system of equations is usually two equations, but we can have three or more. Most of the time when we're working with these problems, it is two though. Okay, for example, 4x plus 5y equals 1, as well as negative 3x minus 5y equals negative 7. This would be a good example of a system of equations, okay? Especially one where we are doing the elimination method or solving them by elimination. Same words, different words, same idea. Okay, so we want to eliminate one of the variables. We usually do this by adding the two equations together. Okay, so an example, 4x plus 5y, and the answer is cut off, okay, but we don't really need that answer. So our goal is either going to be to eliminate the x's, which that's not going to work. If I add those together, 4 plus negative 3 is 1. We didn't get rid of it. It's still there, okay? Some people think that there's a 0 in front of the x. Obviously, we know that that's wrong. There's a 1. So, well, what about adding these two together? Yay, okay, that would be correct. 5y plus negative 5y, or 5y minus y, is going to be 0, and then that would give us our answer, okay? So if we just come back over here, we can actually see the answers that are supposed to be there, 1 and negative 7, and when we add those together, we would get that negative 6 that is been hidden here in our diagram by the just saying. Okay, so then that's my answer, right? Okay, but no, it's not. Okay, we also need a y value, okay? Remember that we need to wait until the thing will fade, that the solution is a point, and for that we need to get x and y. We need both of them, okay, guys? So we're going to substitute in x into either equation, okay? So if you choose this first one here, 4x plus 5y equals 1, you're going to replace the negative 6 as your x, and then you're going to solve it just like it's a normal equation from any type of algebra situation, okay? We'll multiply the 4 and the negative 6 to get negative 24. Everything else stays the same, okay? Then we're going to add the 24 to both sides, and that would get me 5y equals 25. How do I get rid of the 5 to get the y by itself? We're going to divide, and that will give me my answer of y equals 5. Remember, the solution is a point, and we need an x and a y to make our point, so we still don't have our final answer yet. Our final answer is going to be putting both of those together to get negative 6, 5, that coordinate or that point, okay? So let's take a look at a second example because there are other situations and we want to make sure we cover those as well. So going over a couple basic ones here today. 7x plus y equals negative 2, 7x plus 3y equals 8. The 7x's cancel out, right? No, they do not. If I add those together, that will be 14, but that's a common mistake that students make. Well, what about the y and the 3y then? They would have to cancel out, right? No, that doesn't make sense either because that would give me 4y if I add those together. So what am I going to do then in this situation when nothing cancels out, which does happen very often, okay? We can multiply one of the equations by -1 and then use the same process as we did in example 1. This is the same thing as subtracting, but trust me, guys, okay? There's way more mistakes when you try to subtract them because you're going to forget about all these little details. But if you want to do that, that does work. Personally, I think multiplying by -1 is the easiest way, and it's going to help you prepare for future problems as well. Okay, so when I multiply by -1, I'm multiplying all three numbers there, the 7, the 3, and the 8. That would make them all be negative. And then we're going to use the other equation from the original problem, and I can add them together the same way as I did in example 1. So when I add them together, those x's will cancel out. -3 plus 1 is -2. -8 plus -2 is -10. And I can divide by -2. Then that will give me y equals 5. Okay. Continuing on, I will substitute the 5 into either one of the problems. I chose that first one because it's going to be easier. That will give me 7x plus 5 equals -2. Subtract the 5's. That gets 7x equals -7. Divide the 7's. Get x equals -1. And remember, it always has to be a point. Every year, I always take off points because no one wants to write their point. Points for points. It's only fair. So, our final answer will be -1, 5, and you need to make sure that you put them in the right order as well. The x goes first and the y goes second in every point always. Okay? And we did it. Now, these problems can tend to be a little bit longer, as you can see here, but writing your workout is the best way to ensure that you're going to get the problem correct. So please be doing that and then submitting it as well. And that will do it for systems and solving them by elimination. Okay, we did two main problems here. The first one would be when we have something obvious that cancels out, and the second one would be where we have the two numbers that are ready to cancel out, like 7 and 7, but they're both positive, or they could both be negative. If they were both -7s, we would follow this same process as well. And there are a couple other situations that can happen in addition to this, and we will take a look at those in the next video lesson. So hopefully this clears up some misconceptions or some difficulties with solving systems by elimination. Thank you so much for watching. I am Mr. Lanigan, and this has been Easy Mode Math.